Hey everyone, how's it going? Welcome back to InfoGamer. For this lesson, we're going to be doing some more networking using the Photon plugin in Unity. So let's get to it. Now before we begin, make sure that you subscribe to our channel and hit the notification bell so you can get updates when we publish new videos. Now some of you have requested that I show more on RPC functions and how to use them in other scenarios for your multiplayer game. So that's what we're going to be doing for this video. We're going to show you how to synchronize a player's health across the network for a game like a first-person shooter. Now the first thing that we need to do is create a variable to hold the player's current health, and I'm going to add this variable to our avatar setup script, which is attached to our player avatar prefab. So I'm going to double click on that script in the inspector, and that will open it up in Visual Studios. So up at the top of this script with all the other variables, I'm going to add a new variable, and this is going to be a public int, and I'm going to call this player health. Let's also go ahead and add a variable for the damage a player can deal to another player. So I'm going to make this a public int and we'll call this player damage. Once we have these variables, let's go ahead and save this script and go back to Unity. Once back in Unity, let's go ahead and set these variables. So for player health, I'm going to make that 100. And for player damage, let's make that 25, so it'll take 4 shots to destroy the player's avatar. Now when it comes to creating any type of a shooter video game, there's really only 2 main ways to go about creating gunfire or bullets. The first is through instantiated game objects, and the second is through what's called raycasting. Now for this tutorial, I'm not going to be able to show you how to create all the mechanics needed for a first-person shooter because this tutorial series is more about the Photon plugin in general. And so for this lesson, we're going to create a very basic first-person shooting mechanic, and we're going to do that using raycasts. But in the future, I'll probably do a whole tutorial series on how to create a first-person shooter with multiplayer. So to create this shooting mechanic, let's go ahead and create a new script for all of our players' combat controls. So within our game controller folder, I'm going to right click, go to create, C# script, and then I'm going to rename this to avatar combat. Let's go ahead and open it up in Visual Studios. Now the first thing that we're going to do within this script is create some variables, and the first variable will be for our photon view. So this is going to be private, and then I'm going to type photon view, and then it's not recognized, so I'm going to click on it, hold Alt and press enter, and I'm going to select using photon.pun. We can then give this variable the name of PV. And our next variable will be for our avatar setup script. So this will also be a private variable. And then I'll type avatar setup. And then let's just call this avatar setup with lowercase a. And finally, we're going to want to create a transform variable to hold the origin of our raycast. And so this will be a public transform, and we'll call it ray origin. The next thing that we want to do is initialize our private variables. And so within the start function, I'm going to type pv equals get component, and then we're going to pass in photon view, and then parentheses, semicolon. Then we're going to say avatar setup equals get component avatar setup, parentheses, semicolon. So now that we've set up our script, it's time for the fun part. We're going to create the shooting mechanic. And so within our update function, the first thing that we want to do is check for player input, because we only want our avatar to shoot if the player has clicked the left mouse button. And so within the update function, I'm going to type if, and then input.get mouse button down. And then within parentheses, we're going to pass in the value for the left mouse button, which is 0. Within this if statement, we can then go ahead and create our raycast. So the first thing that we want to do is create a local variable, and this will be for the raycast hit. So the data type is raycast hit, and then we're just going to call this variable hit. Now before we actually create the raycast, let me briefly explain what a raycast is. A raycast is essentially an invisible line that has a starting point, and you can specify what that starting point is, and then you can specify which direction you want this ray to travel in. And if that line or ray intersects with another object that has a collider of some sort, then it will return that object. And so with that, I hope you can see why a raycast would make for a good bullet. Well, let's go ahead and create our raycast, and we're going to do this by creating an if statement that will both cast the ray and set the hit. And that if statement should look something like this. Now I pulled this if statement straight from Unity's documentation on raycasts, so I'll make sure that I include a link to that documentation in the description below. But we want to modify this if statement so that it works better for our script. And we're going to do that by changing some of these parameters that are being passed into this raycast function. And so this first parameter specifies the origin in which you want your ray to start at. And so rather than using transform.position, we are going to use our ray origin.position. The second parameter specifies the direction in which you want your ray to travel. And so instead of using transform.transform_direction, we're going to use our ray origin.transform_direction. The third parameter, where it says out and then hit, is actually how our raycast function will return the object that our ray intersects with. And so if our ray collides with another object, that object will then be saved within our hit variable. And so we don't need to change that parameter. The fourth parameter is the distance that we want our ray to travel. And so I'm actually going to change ours from mathf.infinity to, let's say, 1,000. And finally, the last parameter specifies whether or not you want any layers to be ignored by your raycast. And for our example, we're just going to get rid of that parameter. Now this if statement will only be true if our ray hits another object, but we want our player to shoot regardless if they're going to hit an object or not. And so we're going to add an else statement as well. Now I've gone ahead to add some debugging to both my if statement and my else statement. And if you'd like to, you can pause the video and copy these down. Now this first debug statement will actually draw a visible line for our ray within the scene view, but that line will not show up within the game view. And if we hit an object, that line will be colored yellow. If we do not hit an object, that line will be colored white. The second debug statements will just print a message to the console whether or not we did hit an object or whether or not we did not hit an object. The next thing that we want to do is check to see what the object is that we hit. And so within our if statement where we have a successful hit, we're going to type another if statement. And so we're going to say if, and then we're going to check to see if hit.transform.tag equals, and we're going to say in quotes avatar. If we hit another avatar, then we want to deliver our avatar's damage to their avatar's health. And that will look something like this. We first want to get the hit object, so I'm going to type hit.transform.gameObject, and then from the game object we can then get the avatar setup script. So I'm going to say .get component, and we're going to pass in avatar setup. From here we can then access the public variables of the avatar setup script. So I'm going to type .player health. We then want to subtract the damage of our avatar from this variable. So I'm going to say minus equals, and then we can access our avatar's damage through this avatar setup variable. So I'm going to copy that and paste it here. And then going to type .player damage. Now this is a very basic way of subtracting damage from health. If I were doing this on my own, I would probably put it all within a function and pass the damage in as a parameter. Now we're not quite done yet. If you've noticed, we haven't done any networking. But let's go ahead and save this, and then we're going to set up our first person camera. So I'm going to hit Control S, and then let's go back to Unity. Within Unity, let's go to our Photon prefabs folder. and let's drag our player avatar into the scene. I'm then going to select our main camera and I'm going to duplicate it, and then I'm going to make it a child to our player avatar. I'm also going to change the projection from orthographic to perspective, and then I'm going to reposition this camera so that it is located where I think the eyes of my character will be. I'm then going to apply the changes to our prefab, and I'm going to remove it from our scene. I'm then going to select our player avatar within our project window, and I'm going to open up the avatar setup script. Within our avatar setup script, I'm going to create two more variables. One will be for our camera and one will be for the audio listener. And so the first one will be a public camera, and then we'll say my camera. And the second one will be a public audio listener, and this will be my AL. And then all we have to do is destroy the value of these variables if we are not the local player. And so in our start function, after the if statement where we check to see if we are the local player, I'm going to type an else statement. And within this else statement, I'm going to say destroy, and then I'm going to pass in my camera, and I'm going to say destroy, and I'm going to pass in my AL. We can then go ahead and save the script and go back to Unity. I'm then going to select our player avatar prefab within the project window, and I'm going to expand it. I'm then going to click and drag the main camera game object into the my camera variable and the my AL variable. And then the next thing that we need to do is select our child camera game object and change the depth from -1 or whatever it is to something greater. And so I'm going to change it to 0. So now that we have our first person camera set up, let's go back to our avatar combat script where we will network our shooting mechanic. Now for the script, because we're not networking anything at the moment and we're not checking to see if we're the local player, what would happen if we built this game right now is anytime a player clicks the left mouse button, we would basically raycast from all existing avatars across all clients. But none of those raycasts would actually be synchronized across the network. And so we don't want that to happen in our games, so let's go ahead and fix it. But before we do so, I want to make one thing perfectly clear, and that is, as I've been creating this shooting mechanic, I basically created it for a single player game. And so if you want to create a feature for your multiplayer game, all you really have to do is create the functionality as if it were for a single player game, and then follow the next steps that I'm about to do. So first off, we want to make sure that we're only shooting if we are the local player. And so inside our update function, I'm going to create a new if statement, and this if statement is going to check to see if we are not the local player. And if we are not the local player, then we are going to return out. So I'm going to type if not pv.isMine. If we are not the local player, then we will return. And so if we are the local player, we will skip this if statement and continue on through our update function. The next thing that we need to do is create an RPC function. So I'm going to scroll down to the bottom, and here I'm going to add the tag PUN RPC, and then this is going to be a void function. I'm going to call this function RPC underscore shooting. And then what I'm going to do is I'm going to cut everything inside our if statement checking for our player's input. So from the Raycast hit variable down to the bottom of the else statement. I'm going to cut that and I'm going to paste it in this RPC shooting function. Then all we have to do is call this RPC function inside the if statement that we just cut everything from. And so I'm going to type pv.rpc, and then inside we're going to call the function by its name, so RPC shooting. I'm going to put that in quotes. The second parameter specifies who we want this RPC function to be sent to, and so this is going to be RPC target.all. And our RPC shooting function doesn't have any of its own parameters, so I'm going to leave this line with the semicolon. Now remember, this is a very basic shooting function and it is in no way perfect. The purpose of this tutorial was not to create a first-person shooter, but instead to demonstrate how to use RPC functions in other scenarios within a multiplayer game. It was also meant to show you how you can really take any function that would be meant for a single player game and convert it into something that would work within a multiplayer game. Now, the last important principle that I want you to take away from this tutorial is on when to call an RPC function. Unity provides special functions that will execute at certain times and intervals within your game. These functions are such as the start and update functions, but there's other functions as well, such as the onCollisionEnter function. And so if you want to synchronize information across the network at the beginning of your game, such as maybe the player's names or the player's avatars or loadouts, then you're going to want to use the start function to send that RPC. This is similar to what we did in our last video where we synchronized the player's avatars at the start of the game. If you want to synchronize what happens to a player when they collide with a certain object, then call the RPC function in the onCollisionEnter or onTriggerEnter function. And finally, you can call an RPC function within the update function as we have done in this tutorial, but with that you want to make sure that you meet special conditions before you call an RPC function, and that way you're not sending an RPC every single frame. With that said, it's time to save our script and go back to Unity. Within Unity, we first want to select our player avatar prefab, and then I'm going to attach our avatar combat script. So I'm going to click Add Component, I'm going to type in avatar, and then select Avatar Combat. We then need to drag in the transform for our camera. So I'm going to expand our player avatar, I'm going to scroll down, select our main camera, and then drag it into that field there. The last thing that we need to do for our player avatar prefab is add a tag. So I'm going to scroll up and select the tag drop down menu. I'm then going to go to add tag. I'm then going to click this plus sign and I'm going to type in avatar. And it needs to be spelled the same way as we're spelling it in our script. I'm then going to go back to our player avatar prefab. I'm going to select the tag drop down menu and then select avatar. Now that we've done all that, I believe it's time to test our game and hopefully it'll work. So I'm going to hit Control B and then it'll take some time to build. Once our project is finished building, we will then hit play on the standalone and play in the editor. I'm then going to select one of the characters and then I'm going to hit battle. Now within the game view you can see that we can no longer see our avatar, and that's because we changed our camera so that we have a first person perspective. But within our scene view, you can see that we still have our avatar and you can see that the camera is positioned at their eye level. Now let's go to our standalone and do the same things. So I'm going to select a character and I'm going to hit battle. And here you can see that we're now in the scene, and I'm going to see if I can spot, except for, oh, we're right on top of each other and that's why I can't see. So I'm going to move my character and there you go. We can now see the other avatar. I'll rotate around right there. Now what I'm going to try and do is shoot one of the avatars. And I'm going to do this from the Unity editor. So I'm going to scroll over and then I'm going to click in my scene, and it might be a little hard because I have a mouse. Did not hit. So we are getting a message that says that it did not hit. For some reason it doesn't seem to be drawing any lines, and it's probably not drawing a line because it's one single frame, and so that one single frame is hard to see. Now oh yeah, I saw a little glimpse of a line. Yep, you can see the line. So hopefully somewhere in there I hit, oh there we go, yeah. The console now says that we have a hit. So I have did not hit, and then I have hit. And so let's see if we have any different health. So I'm going to select our avatar, scroll down to the avatar setup, and there you go. This avatar, which is the second avatar, the avatar of our standalone, has 75 health, whereas my first avatar has health of 100. Now it looks like everything's working, but just to make sure, I wanted to make some quick changes to our game so that I can better demonstrate everything that we've done. And so let me run through those changes real quick. Now the first change that I made was to add this little reticle, which signifies the center of our camera. And this is just a simple UI image that I colored red. And this helps us know where our array will go. The second change that I made was to add this text object in the bottom right hand corner of our camera. And this will display our player's health. And then another change that I made was that I moved the spawn points so that they have the same value for their Y position, and then I spaced them out in the X direction, and that way they'll be on the same plane and they'll be able to shoot at each other. And then I made some changes to our script where within our avatar combat script I changed this from being get mouse button down to just get mouse button, and that way anytime we're holding down the left mouse button we'll be shooting every frame. And I only did this so that we can better see the line that is drawn by our debug statement. And finally, the last change that I made is that I added a text variable to our game setup script, and then within our avatar combat script we get that text variable and save it within a text variable within this script, and then in our update function I update that text script so that it reads out our avatar's health. Once the project's finished building, we will again hit play in the standalone and play in the editor. I'm then going to click battle, and here you can see we have our reticle and we have our health. And this text object was first set to 0, but now it's 100, and so we know it's updating our player's health. Let's go over to our standalone, and I'm going to select a different character. I'm going to click battle. And there you can see we're now in the scene, and if I move and then rotate, you can see that we can see our other avatar. Now I'm going to click and shoot at our avatar, and there you can see within our editor that we now have health of -275, and that's because just within the short time that it took me to press and release the left mouse button, there were 15 frames that were executed. And so there were 15 separate rays that were sent out and collided with our other avatar, subtracting 25 each time. Now I'm going to switch over to our editor, and I'm going to click our scene and then go to 3D view. And now as I move around and if I click and hold, you can see our ray that's being drawn by the debug statement. And right now it's white because we're not colliding with anything. But if I move to our other character and start colliding with him, you can see that it then turns to yellow because we are hitting this character. And if I go back to our editor, you can see that we now have health of -17,100. And then if we go back to our editor and we select that avatar, you can see within our avatar setup script that the health is actually -17,300. And I think the discrepancy there is because we were literally sending an RPC function every single frame, which is a lot of work, and I'm sure some of the RPC functions were dropped. One way to fix this would be to send another RPC function, probably from the player that was hit, broadcasting their health to all the other players. Now it looks like everything's working, so I think that's where we'll conclude this tutorial. I hope you enjoyed this lesson and that you found it to be helpful. You should now have a better understanding of RPC functions and what they can do, and also when it is appropriate to send them. You should also have a better understanding on how to take really any game mechanic that will work for a single player game and modify it so that it will synchronize across the network and work for a multiplayer game. If you have any questions regarding these principles, make sure that you leave them in the comments below. Also subscribe to our channel so you can be up to date on all our latest videos. Thanks for watching, and we'll see you next time.